Hi, I'm Liz Heinecke, the author of The Kitchen Pantry Scientist, Chemistry for Kids. And today I'm in the Quarto classroom to teach you a little bit about science. I thought I'd start by giving you an overview of the book, reading about one of the scientists, and then I'm going to show you how to do a really fun chemistry experiment using things you have in your own kitchen. So this book tells the stories of 25 scientists, mostly chemists, past to present, from a few thousand years ago to today. And it's beautifully illustrated by an artist named Kelly Ann Dalton. You can see this is the first chemist whose story I tell. Her name is Taputi, and she made perfumes and lotions and essential oils for the royal family in ancient Mesopotamia. Then, after I tell a scientist's story in the book, let's see, I have a project related to their work. So for Taputi, I have a project where you can make essential oils using distillation methods very similar to the ones that Taputi used so long ago. I cover lots of scientists. I talk about Joseph Priestley, who there's a carbonation experiment. You can see that he actually was the first person to figure out how to carbonate drinks. So thank you, Joseph Priestley, for soda, right? And fizzy water. I have a fun experiment related to chemical reaction rates that you can do using oil and water and seltzer tablets, where you test whether chemical reactions happen faster with hot water or cold water. That's a really fun one. And I talk about Marie Curie, who did really amazing things. She was the first person to figure out how to measure radioactivity, and she discovered 2 radioactive elements. She's one of my favorite scientists. And finally, like a current present-day scientist, this is Dr. Rachel Burks, who is a chemist who works on chemical sensors. So she works on making small portable machines that can sense chemicals such as, and you can see in the illustration here, such as caffeine, like the caffeine in coffee, or even materials you find in explosives. So she does really important work on chemical sensors. But the scientist I am focusing on today is named Agnes Peckles. And one of the reasons that I wanted to tell you about her is because she is a woman who was not really allowed to have a formal education or do science formally, but she loved science so much that she figured out a way to do it at home and made important contributions that scientists still use today. So I'm just going to read her story, and then I'm going to show you how to do this fun experiment. All right. Agnes Peckles was born in Venice, Italy in 1862. Her father was an officer in the Royal Austrian Army, but when she was 9 years old, he became very ill with malaria. Malaria is a horrible disease that's carried by mosquitoes. Her family moved to Brunswick in Lower Saxony, which is now a part of Germany. Although she attended a high school for girls and was fascinated by science, women were not accepted into the universities. She wanted nothing more than to continue her studies, but was forced to remain at home to take care of her 2 ailing parents while her brother went off to college. Not fair, huh? Fortunately for the field of chemistry, Agnes's curiosity was unstoppable. She began to notice interesting phenomena while washing dishes in her kitchen sink. Fascinated by how oils and particles formed films on water, she observed that these films could be disturbed by soap and other materials. Agnes transformed her kitchen into a research station and dove into the study of surface tension, which is the name for the way molecules stick together on the surface of a fluid. Her brother Frederick, who was studying science at the university, recognized his sister's hunger for knowledge and supported her in every way he could. Besides observing her work, he gave her access to a physics journal so that she could learn what other scientists were doing in their more well-equipped laboratories. By the time she was 20, Agnes had invented a slide trough, which allowed her to play with the way a liquid surface behaved by sliding a wire or metal strip across the top of it. And in this picture of Agnes, you can see that Kellyanne Dalton has drawn sort of an image of what a slide trough looked like, such as the one that Agnes invented. And there in the background, you can see her, her pot full of dirty dishes. She used her slide trough apparatus to create very thin layers of fluids and then to test the effects of different contaminants, such as fine powders or soaps on surface tension. Besides discovering methods for applying uniform layers of particles to a surface, she discovered that her trough could sweep a surface free of surface contaminants. And that's kind of interesting if you think about that. Why would you want to sweep surface contaminants off a fluid? Think about oil spills maybe, right? It's important work. Agnes shared her results by writing a letter to another scientist who studied the surface of liquids. He was impressed, and eventually her work was published in the famous journal Nature. She was delighted to learn that other scientists were using her research results and trough design now in their own laboratories. Agnes Peckles continued studying surface tension, and her work led to many discoveries and innovations in surface tension and materials science. The last part of this story is called A Kind Heart. Agnes Peckles' brother died in 1913, and following World War I, her beloved physics journal was no longer published. She lived out the rest of her life in relative obscurity, which means that no one really knew who she was, but she was always helping others. 4 years before her death, Agnes was awarded the Laura R. Leonard Prize of the German Colloid Society for her quantitative investigation of the properties of interfaces and surface films. That's a mouthful, isn't it? And for the methods she used, which have since become fundamental in modern colloid science. So she really, really did important work on surface tension. So if you flip to the next pages of my experiment, you can see Amber Procaccini's beautiful photographs, but I give instructions on how to do this experiment that I'm about to show you, along with another one with oil and water. And then I always tell at the end of each lab the story behind the chemistry, because I want you to know what the fun, I mean, this is all really fun, but it's kind of cool to understand why what you see happening is happening. Okay. So to do this project, which I've always called tie-dye milk, because you'll see it kind of looks like tie-dye, all you need is some milk. You can use any kind of milk or experiment with different kinds of milk. A shallow dish, like a plate. You could use a smaller plate or a bigger plate. You need some dish soap. Doesn't have to be blue. Any dish soap will work, dish detergent. And some food coloring. And then if you have them, these cotton swabs are nice for putting the soap onto the plate. So the first thing you do is you're going to put a thin layer of milk onto the plate. And what happens when you pour a thin layer of liquid onto a surface is that all of the milk molecules, now remember milk is mostly made of water, all of the milk molecules that are sitting between the liquid and the air stick to each other really tightly because they have no interest in sticking to the air, but they really like sticking to each other. Water molecules love to stick together. So they actually form this film that you can't see, but we'll sort of be able to see what happens with it on top of the surface. And scientists call this phenomenon surface tension. So when I was talking about Agnes Peckles studying surface tension, this is what we're talking about. All right, so surface tension is forming this film. You can imagine it kind of like a skin or like the plastic on a balloon. And all of the liquid underneath can move around, but the surface tension on the surface, it stays pretty still. So I'm going to take some food coloring and drip it onto here. And the food coloring, you can see it makes some dots, but they don't move around. They start to move out a little bit, but they don't move around a lot because the surface tension of the fluid is holding them sort of underneath and holding them kind of still. But if I break this surface tension, we'll be able to see that the food coloring moves around. And to break the surface tension, we are going to use a chemical called a detergent. And detergents are kind of like chemical knives. They're really good at breaking surface tension also breaking up oils and fats, like the fats you find in milk. So all I've done is squirt some dish soap. Can you see this? I squirted some dish soap into the water. Now I've purposely put the camera up high so you should be able to see what's happening here. But to break the surface tension on the milk, all I have to do is touch the soap to the surface. Okay, so let's try this. 1, 2, 3. How cool is that? So the dish soap broke the surface tension of the milk, and all of the food coloring now is free to move around. So I'm going to touch the edges of this with some more soap to really get this food coloring moving around. But you can see it just makes these gorgeous patterns in the milk. And these are really fun if you like to take pictures for social media or just for fun. It'll keep moving around and forming these gorgeous patterns on the milk. So another project you can do is you can put oil in a shallow dish, and you can put some food coloring and water on it, and then you can, this is the other experiment in this book, you can spray it with rubbing alcohol. That's parental supervision required, and do it outside. But you can really make some beautiful patterns, and it's fun to watch these fluids move around. Some people also, if you don't have Q-tips, you can also just sort of drip the soap right onto the liquid to break the surface tension. And it'll just keep moving around. You see, there it goes. I wish I could hold this up so you could see it really well, but I think it'll slosh all over the place. Anyway, thank you for joining me in the Quarto classroom. This was a lot of fun. If you're interested in purchasing my book, you can find it everywhere books are sold. And if you do this project, take a picture of it and share it on social media. Be sure to tag me at Liz Heinecke. It's LIZHEINECKE. And use the hashtag Quarto Classroom. So it was nice doing science with you. Thanks.